Hello everyone, welcome back to another video. This is the sixth part of environmental statistics in which we are going to learn about hypothesis testing. For better understanding of this topic, you must watch the previous videos. In case if you haven't seen them, you can check it from the link given in the description. In today's video, we will discuss that what is hypothesis, what are the types of hypothesis, the procedure involved in hypothesis testing. We will also see the null and alternate hypothesis and the types of errors we make, that is type 1 and type 2 decision errors, how we define the alpha and p value or the significance and confidence limits. These statistical tests used for hypothesis such as chi-square test, t-test, z-test, f-test and ANOVA will also be discussed in detail, and at last we will also see some questions, so make sure to watch till end. Starting with the hypothesis itself, now let's know that what is hypothesis and what are its types. Hypothesis can be defined as any statement or assertion about a statistical population or the value of parameters. For better understanding, let's take an example. Suppose we have to check that whether there is microplastics in river water or not. So for this, we can't examine the whole population as practically it is not possible, right? So what we do, we take a random sample from the population and examine it. If the sample did not match with our hypothesis, we will reject it. So, in simple words, we can say that a hypothesis is a statement which we assume and it is to be tested and yet to be proved. Hypothesis can be of two types. First is simple hypothesis, which specifies the population completely, as here the probability distribution and all the parameters are known. Second is composite hypothesis, which do not specify the population completely, as here either the form of probability distribution or some of the parameters are unknown. Next, let's know about the test of hypothesis. Test of hypothesis is a procedure which specifies a set of rules for decision whether to accept or reject the hypothesis under the consideration. There are 5 steps for hypothesis testing. First is to state the null and alternative hypothesis. Second is to select a significance level or alpha value. Third is to calculate the test statistics, in which there are different parametric and non-parametric tests including z-test, t-test, chi-square test or f-test. Fourth is to calculate the p-value and decide the age of hypothesis, and last is to get the interpretation of our result. For testing any hypothesis, first we have to set null and alternative hypothesis. Let's take the example as in order to test the microplastics in the river, first we will have to assume that there is no microplastics in it, and this will be our null hypothesis. So we can say that the null hypothesis is the hypothesis which is set up for possible rejection on the basis of sample observation. Null hypothesis is denoted by H0 and it is tested against the alternative hypothesis. Null hypothesis is tested for possible rejection under the assumption that it is true. In opposite to it is the alternative hypothesis, which is the negation of the null hypothesis, denoted by H1 or H alpha. This hypothesis is not tested, but its acceptance or rejection depends on the rejection and acceptance of the null hypothesis itself. The null hypothesis predicts that there is no relationship between the two variables, whereas the alternative hypothesis predicts that there is relationship between the two variables. In other words, we can say that the null hypothesis shows no significance, which is to be tested, and after testing this we will get our result either to accept the alternative hypothesis or reject the alternative hypothesis on the basis of null hypothesis. One important point is that the null and alternative hypothesis are mutually exclusive, which means either the null hypothesis will be correct or incorrect, or the alternative hypothesis will be correct or incorrect. We have just learned that the test of hypothesis deals with the acceptance or rejection of the null hypothesis only, and it is the alternate hypothesis which contradicts the null hypothesis. While hypothesis testing, we may occur some errors which are the type 1 error and type 2 error. The type 1 error is also known as false positive or alpha error, whereas the type 2 error is known as false negative or beta error. The type 1 error occurs when we reject a null hypothesis that is actually true in the population. So here, as we are rejecting a null hypothesis that is actually true, that is actually positive, so that's why it is known as false positive. And the second type of error is the false negative error, in which we fail to reject a null hypothesis that is actually false. So again it is talking about null hypothesis, it is false and we are accepting the false null hypothesis. So it is known as false negative. That means the null hypothesis is not true, yet we are accepting false negative, and the null hypothesis is true but we are rejecting, so it's false positive. One important point to note is that the type 1 error, which is also known as alpha, may be due to the internal risk, whereas the type 2 error, which is also known as beta or can be represented as 1 minus alpha, that is the power of test, may be due to the systematic risk. The type 1 error, where the true null hypothesis is rejected, is a very dangerous condition, and for this we have to decrease the value of alpha, which is known as the level of significance, which we will learn after few minutes. For the type 2 error, we must increase the value of alpha and sample size. Before learning about the value of alpha or level of significance, let's know about the confidence level. For example, if we calculate the mean of any sample, which comes out to be 20, and we take our confidence interval, which will be equal to maybe 5. So for this we have to first decide the confidence level. The confidence level can be of 90%, 95% or 99%. The confidence level shows that how much confident we have that our collected value will be in the range of the confidence interval. Now let's see that what the 90% confidence level means. The 90% confidence level means that we are 90% sure and there is only 10% chance that our calculated value will be in the outlier. For the 95%, we are 95% sure and there is only 5% chance that our calculated value will not lie in the range which we have chosen. So the confidence level represents the level of confidence, and more the level of confidence, less chance of error will be. As here we have taken that our mean of the sample is 20 and the confidence interval is 5. So by this we get that our value will lie in the range of from 15 to 25, and if the value doesn't lie in the range, or the range which is outside it, is known as the alpha or the level of significance, which means that for 90% confidence interval the alpha is 10%, for 95% confidence level the alpha is 5%, and for 99% confidence level the alpha is 1%. Next, let's know about one another important term, that is critical region. The critical region is the region with the set of values of the test statistics that leads to the rejection of null hypothesis, whereas the acceptance region is the set of values for which the null hypothesis is not rejected but is accepted. As here you can see, this is the rejection region, that is the critical region, and this is the non-rejection region or acceptance region. The critical value is a number that separates the rejection and the acceptance region. One important point to note is that if the calculated value is less than critical value, then we will accept the null hypothesis. But if the calculated value is more than the critical value, we will reject the null hypothesis. Now let's know that what is significance level and p-value. This significance level is also known as alpha or p threshold, and it is the probability that you will make the mistake of rejecting the null hypothesis when it is true. So it is talking about the H naught, that is null hypothesis, and the error that we are going to make is the alpha error, that is type 1 error. Whereas the p-value measures the probability of getting a more extreme value than the one you got from the experiment. So after doing the test and getting a result, we have to check whether our p-value is greater than alpha or is smaller than alpha. If p-value is greater than alpha, then we will accept the null hypothesis, whereas if p-value is less than alpha, then we will reject the null hypothesis. Now let's discuss some statistical tests for hypothesis testing. In short, first is the chi-square test. Chi-square test is generally used for the large samples, that is, the sample size must be greater than 50. The chi-square depends on the degree of freedom, and for calculating degree of freedom we just have to subtract 1 from the number of values in any data set. The chi-square is used to test the goodness of fit between theory and experiment, and its formula is observed minus expected frequency whole square divided by expected frequency. Second is the t-test, which is used for the small sample size and it varies with the degree of freedom. It is assumed that the t-test follows the t-distribution which is nearly equal to the normal distribution curve. t-test is used for testing the significance of differences of mean, and the formula for t-test is equal to sample mean minus population mean upon standard deviation divided by under root n. The z-test is used when the sample size are large, and it also follows the normal distributive curve. Z-test is used for testing the significance of mean, and the formula for using z-test is equal to sample mean minus population mean divided by standard error. Last is the ANOVA, which is also known as analysis of variance. It is used in three conditions. First is the independence of case, second is normality, and third is homogeneity. ANOVA is used for the comparison of data for more than one samples, and here we calculate the mean square, which is equal to the sum of square deviations from mean divided by degree of freedom. Now let's see some questions to recall what we have learned today. After reading the question, I will wait for some seconds so that you can also guess the answer. The first question is, consider the following statements pertaining to sampling theory which are correct. Statement A is, the standard deviation of the sampling distribution of a statistic is known as its standard error. Statement B is, the precision of the sample estimate of some population parameter is the reciprocal of the standard error of the sampling distribution of the estimate. Statement C is, a type 1 error in hypothesis testing occurs when we accept a wrong null hypothesis. And statement D is, a type 2 error in hypothesis testing occurs when we reject a true null hypothesis. So here, as statement C and statement D are incorrect, our correct option will be option 1, that is statement A and B. Here, the type 1 error is the false positive error where we reject a true null hypothesis, whereas the type 2 error is a false negative error where we accept a false null hypothesis. Next question is, which of the following is an example of type 2 error? Statement A is, the probability of not rejecting null hypothesis when it is actually false. Statement B is, probability of rejecting null hypothesis when it is actually true. Statement C is, when a drug is actually effective but declared as not effective. Statement D is, when a drug is actually not effective but declared as effective. And statement E is, when a person is actually not having diseased but declared as diseased by a physician. So here our correct option will be option 3, that is statement A and C. Next question is, which of the following facts are correct related to p-value? A is, it is the probability of type 2 error which is fixed in advance. B is, it is the probability of type 1 error which is calculated based on data. Statement C is, it is the probability of type 1 error which is fixed in advance. Statement D is, it should be less than the level of significance for having significant result. And E is, it is the probability of type 2 error which is calculated based on data. So here our correct option will be option A, that is B and D. Next question is, which of the following statements regarding sampling are correct? Statement A is, the sample mean is an unbiased estimate of the population mean. Statement B is, for small samples the sample variance is an unbiased estimate of the population variance. Statement C is, if we reject the null hypothesis when it is actually true, we commit the type 1 error in testing the hypothesis. So here our correct option will be statement A and C. For every sample, the sample variance should be unbiased estimate. It doesn't depend on the sample size. Last question, we have to match the statistical test with its application. So here our correct option will be option third, that is the chi-square test is used for testing the goodness of fit. The one-way ANOVA is used for comparing means which are more than one. Pair t-test is used for testing the significance of differences of mean, and z-test is used for testing the significance of a single mean. So that's all for today. Hope you liked it. Till then, thanks for watching.